People often talk about AI as if there is a hidden mind inside the machine. This video takes a different approach. We are going to strip away the magic and look at a simpler, more useful explanation. The basic idea is that AI is not a digital person. It is a system that learns patterns from data and uses those patterns to generate likely next outputs. When AI gives a smooth, impressive answer, it can feel like there is an expert sitting behind the screen. It sounds as if the system understood your question, thought about it, and then decided what to say. That feeling is powerful, but it can also be misleading. A lot of confusion about AI begins right here with the mistaken idea that fluent output must come from human-like understanding. A better mental model is to stop comparing AI to a human mind. Human beings read ideas, understand meaning, know facts, and reason about what is true. AI models work differently. They process tokens, calculate probabilities, detect patterns, and generate likely text. That does not make them useless, it just means they are doing a different kind of work than many people assume. At the core, an AI model is a prediction engine. Give it a phrase like the sky is, and it does not stop to think the way a person would. Instead, it calculates which continuation is statistically most likely based on patterns it learned during training. In many contexts, blue may come out ahead of other options. That is the basic mechanism, not inner understanding, but next step prediction. AI also does not process language the way we do. It does not naturally read complete words as humans read them. Instead, text is broken into smaller pieces called tokens. A token might be a whole word, part of a word, or even punctuation. So, when you type a sentence, the model is really working with a sequence of chunks. That is one reason AI handles language mathematically rather than intuitively. Once text becomes tokens, those tokens can be turned into numbers. From there, the model can compare patterns and estimate probabilities. This is the most technical-looking slide, but the main idea is simple. The model is not asking, "What does this mean in life?" It is asking, given these numeric patterns, which token is most likely to come next. That is how language becomes something a machine can calculate. When people hear the phrase training, they often imagine something like teaching a student. But AI training is not learning in the human sense. The model is exposed to huge amounts of text so it can map which words, phrases, and structures tend to appear together. It becomes very good at pattern relationships. That is different from building a grounded understanding of reality or knowing facts the way a person can. This leads to one of the most important points in the whole presentation. The model can learn how language usually flows without having any built-in truth checker. In other words, it can produce sentences that sound right because they match familiar patterns, even when the content is false. It knows how text is often shaped. It does not automatically know whether a claim matches the real world. This also explains why models sound so confident. Human writing often uses a polished, finished tone, especially in articles, reports, and explanations. AI models learn from that writing style and reproduce it. So, confidence in AI output is often just a style signal, not a truth signal. A sentence can sound certain, clean, and authoritative while still being wrong. Fluency and accuracy are not the same thing. When a model does not have a reliable answer, it may still produce something that sounds plausible. That is what people usually call hallucination. The model is not necessarily trying to deceive anyone. It is continuing the pattern in the most statistically likely way it can. If a made-up date, source, or name fits the pattern of a strong answer, it may generate that too. That is why plausibility can overlap with error. So, how should we use AI in real life? A helpful rule is to treat it as a tool, not an oracle. It is strong at language support, summarizing, organizing rough thoughts, rewriting, brainstorming, and drafting, but it is weak at reality verification. You should not trust it blindly for exact facts, medical decisions, legal interpretation, or checking live real-world data. It can help with expression, but humans still need to confirm reality. If you remember only one practical lesson from this video, let it be this: use AI to produce language and use humans to confirm reality. That single rule removes a lot of confusion. AI is often very useful when the job is phrasing, structure, or communication. But when the job is deciding what is true, current, accurate, or safe, human judgment and verification still matter. So, the best way to think about AI is not as a digital person or a hidden expert. It is a pattern engine. It is trained on data, it detects relationships in that data, and it generates likely continuations. That simple mental model explains a lot: why models can sound smart, why it can be useful, why it can be wrong, and why its tone can feel more trustworthy than it really is. Once you understand that, AI becomes much easier to use well.